Hello guys, good evening. You are welcome to my YouTube channel, the Explicit Tutorials. As you all know, my name is Tutor Joseph, and in today's video, I shall be introducing us chapter 2 of Chem 113, a topic called Elemental Analysis, Formula and what Structure. Now, in this topic, we are going to be identifying certain compounds and how they are actually tested and the change in what color. Let us get started. Please, as you're watching, please, I'm begging, endeavor to what subscribe. Now, we are going to be discussing elemental what analysis. How are elements analyzed? First thing first, we are going to be discussing identification of what. The first one is identification identification of carbon and what? Carbon and hydrogen. Identification of what? Carbon and hydrogen. In doing this is what we are going to do. We are going to hit a dry copper 2 oxide. We hit a dry copper. Let me get a better marker, please. Right, we are going to hit a dry copper 2 oxide in the presence of these two elements, like carbon, then hydrogen. We are going to hit this copper 2 oxide in the presence of what? These two elements. As such, copper will be produced, carbon 4 oxide will be produced, and water will be what? Produced. So when copper 2 oxide is heated in the presence of two elements, carbon and hydrogen, there are three compounds formed. Okay, there are three products formed. You have copper, you have carbon 4 oxide, and you have what? Water. The equation isn't what? Balanced. You have two hydrogens, so I'm going to be putting 2 here. Okay, I have 3 oxygen, so I'll put 3 here to balance this oxygen. It means I'll write 3 here. So this is what? How to identify what? Carbon and what? Hydrogen. Now please, you can see now that carbon 4 oxide and water were formed alongside copper. Now you agree with me to the fact that carbon 2 oxide turns lime water milky. Yeah, that is carbon 4 oxide, sorry. Carbon 4 oxide turns lime water milky. Lime water is actually calcium oxide. This what? Lime water. This lime water, okay? Now water, which is another compound formed, turns a white anhydrous copper to tetraoxo sulfate 6 blue. All right, now as soon as this water is reacted with a white anhydrous, that is copper 2 sulfate that has no water, when it's reacted with water, it changes from white to what? Blue, which means that from this reaction we can say that carbon 4 oxide turns lime water milky. We can also say that water turns white anhydrous copper 2 tetraoxo sulfate 6 blue. That is white to what? Blue, not blue to white. Please take note of that. Now we can also, that is number 2 is what? Identification of number 2 identification. Oh god, these markers are not bright enough. Please let me pause the video. All right, so I've gotten a better marker. Now the number 2 of it is what? Identification of sulfur, nitrogen and halogen. Now, to identify sulfur, nitrogen, and halogen, Larsen sodium fusion test is what used to identify sulfur, nitrogen, and halogen. Larsen sodium fusion test is what used. I can also say sodium Larsen fusion test. They are the same thing. So please, this is how you can actually identify these three idiots. How do we do it? You and I know that chlorine is a very reactive element. If you are reacting it with this entity here without being careful, it can lead to what? Explosion. Explosion, it will just shatter the test tubes in the lab. So how do we do it? Now we get sodium. We'll heat sodium to what? Red hot. We'll heat it very well. As soon as it, don't forget, it's being heated in a test tube. After heating it to red hot, now this sodium in the test tube is taken to what? Is transferred to mortar, having what? Distilled water. Having distilled water. After heating sodium to red hot in the test tube and the sodium are transferred to what? Mortar that has what? Distilled water. Then in this case, the sodium together with the test tube cannot shatter, they will break into pieces. But if they don't break into pieces, what would you do? You grind it yourself. After grinding, you what? Stir. So that is how the reaction is. Now it is illustrated like this. Oh, I've run out of topical. Now I have sodium. If I should react sodium with chlorine in this manner, don't forget fusion. We have what? Sodium chloride. If I should react sodium with sulfur in this manner, I'll get sodium sulfide. Okay. If I should react sodium with cyanide, okay, this cyano, that is fusion, I'll get what? Sodium cyanide. This cyano, but this cyanide, sodium what? Cyanide. Okay. Apart from this sodium cyanide, I can also have what? Hydrogen cyanide. Okay, it's just like reacting H with cyano to have what? Hydrogen what? Cyanide. So this is Larsen sodium fusion what? Test. So now let us now analyze how each element is what? Tested. Each element, like how sulfur is detected, how nitrogen is detected, and how halogen is what? Detected. Now, identification of sulfur only. Identification of sulfur. Now, to identify sulfur, you can see now that we have sodium sulfide. In the presence of this sodium sulfide, lead acetate is what? Is added or is converted to what? Lead sulfide. Like I have now, when we did the reaction, we had what? Sodium sulfide. So this lead, all right, this lead is reacted with this what? Sulfur. Now these two cannot get out. I'll now have what? Lead sulfide. Now this is what? A black precipitate. The sodium sulfide formed initially is reacted with what? Lead acetate, or just lead. In doing that, you can see now that they have the same charge. You cancel them, you now have what? Lead sulfide. And lead sulfide is what? Black in color. So the presence of this black precipitate indicates the presence of what? Sulfur. Please, sulfur is also tested using what? Confirmatory what? Test. Using a confirmatory test, the sample is added to dilute. Now this sample gotten is added to what? Dilute sodium nitroprusside. The IUPAC nomenclature of sodium nitroprusside is sodium hexacyanates. Okay, let me do it like this. I have CN okay, this is sodium. Okay, good. This is sodium hexacyanates, ferrite nitrosyl 3. Right, so this is the IUPAC nomenclature of what? Sodium nitroprusside. Sodium nitroprusside is what is here. This is the chemical formula of sodium nitroprusside. So please, testing a particular compound with sodium nitroprusside, if there is the presence of pink or purple color. If pink or purple color emanates, it indicates the presence of what? Sulfur. Please, if pink or purple color emanates from this sodium nitroprusside, it connotes the presence of what? Sulfur. Please take note of that. Then how do we identify nitrogen? Identification of what? Nitrogen. Identification of nitrogen. Now, when a ferrite sodium is reacted with what? Cyano, there's formation of what? Ferrite cyanate, hexacyanate. Yeah. Ferrite. It is not easy. Alright. So if I should react this ferrite ion with cyano ion, I'm going to be having what? Ferrite hexacyanate. Ferrite hexacyanate. Cyanate. Alright. Ferrite okay. 6. There's 6 here. Hexacyanate. Now this hexacyanate produced, I have FeCN in the presence of sulfuric acid. There is what? Prussian blue. Is it Prussian blue? Now the presence of this Prussian blue indicates the presence of what? Nitrogen. Please, during the testing or during analysis of elements, the presence of a Prussian blue indicates the presence of which of the following elements? A. Nitrogen, B. Sulfur, C. Hydrogen, D. Carbon. Please, it is what? Nitrogen. It is what? Nitrogen. Please, that is for that. So we've been able to identify sulfur, carbon, hydrogen, and whatever. So please take note of this formula. This is what? A ferrite hexacyanate. When reacted with this, we now have what? A Prussian blue, which connote the presence of what? Nitrogen. Okay, so is that all? No. Now the next one is identification of halogens. Identification of what? Halogens. Remember, we already formed sodium chloride in our initial explanation. Now, in the presence of sodium chloride, in the presence of a nitric acid HNO3 and silver nitrates, in the presence of the nitric acid and silver nitrates, and if I should react this, I'm going to be having silver chloride and sodium what? Nitrate. Silver chloride and what? Sodium nitrate. Now this silver chloride is what? A white compound, and it's a salt. Actually, it's what? A salt. And this white compound is soluble in excess aqueous ammonia. Is soluble in excess what? Aqueous ammonia. And this shows the presence of what? Chlorine. This shows the presence of what? Chlorine. Now, which means that when sodium chloride is added to zinc, silver nitrites, the formation of what? White silver chloride, which is soluble in what? Excess aqueous what? Ammonia. And this means there's what? Chlorine. Now, if sodium bromide, don't forget, we are this identification of what? Halogen. Bromine is an halogen, chlorine is what? Halogen. Now, in the presence of these same entities, HNO3 and silver nitrites, reacting it, I'll have what? Silver bromide plus what? NaNO3. And this guy is off-white. That is, this silver bromide is what? Off-white. And it is sparingly means partially, like it is not completely soluble in what? Aqueous ammonia. So off-white, and which is silver what? Bromide. It is what? Sparingly soluble in excess ammonia. And this shows the presence of what? Shows the presence of what? Bromine. This shows the presence of what? Bromine. Now, if sodium iodide should be reacted with these same entities, I will have what? I'll have silver iodide. I will have silver iodide plus what? NaNO3. Now, this silver iodide is what? Yellow in color. This silver iodide formed is what? Yellow in color, and it is what? Insoluble in what? Excess ammonia. So these are the ways with which you can actually identify halogens. Sodium chloride reacted with this, I'll have what? Sodium and silver chloride, which is what? White. And it shows presence of what? Chlorine. It is soluble in excess aqueous what? Ammonia. Now, if sodium bromide should be reacted with silver nitrite, I will have silver bromide and sodium nitrites, or nitrate rather. I'll now be having what? An off-white silver bromide. And it shows presence of what? Bromine. It is sparingly soluble in what? Excess what? Ammonia. Then when sodium iodide is reacted with this, I will have what? A yellow compound, which is what? Silver iodide. And it is insoluble in what? Excess ammonia. So please, these are the ways halogens can be what? Identified. Now the last one for today is how to identify the contents of what? Nitrogen. How is nitrogen what? Demonstrated? The content of nitrogen, how is it identified? Now, the identification of nitrogen contents in a given compound is done through two methods. One, which is the Dumas methods. Let me explain this Dumas method. Now, in this Dumas method, a sample and copper 2 oxide, that is powdered copper 2 oxide, is what heated in a stream that is in the presence of what? Carbon 4 oxide. Powdered copper 2 oxide is what? Heated in the presence of what? Carbon 4 oxide. As you heat, nitrogen is formed. Nitrogen is what? Formed. As the nitrogen is formed, it follows by oxides of nitrogen. As soon as these oxides of nitrogen are formed, nitrogen gas is formed. I said copper 2 oxide in the presence of carbon 4 oxide is what? Heated. Thereby, the summation of what? Nitrogen. Okay, the nitrogen is converted to what? Oxides of nitrogen, and to what? Nitrogen gas. Now, this nitrogen gas is now passed through what? Hot copper. It's passed through hot copper. Now, after this experiment, if there's any trace of carbon 4 oxide or sulfur 4 oxide, if there's any content of carbon 4 oxide and sulfur 4 oxide in the compound, what will happen? It will be passed through potassium hydroxide. Which means that the function of this potassium hydroxide is to dry this carbon 4 oxide and sulfur oxide from what? This compound. While the nitrogen gas is collected in the nitrometer. As soon as it's collected in the nitrometer, it is what? Measured and what? Calculated. So this is all about the Dumas method. So nitrogen is converted to oxides of nitrogen, and this idiot is converted to this, and it's now passed through what? Hot copper. If there's any trace of CO2 and SO2, it is passed through what? This drying agent, which is what? Potassium hydroxide. Which means it will dry these two idiots, and we are now left with what? Nitrogen gas, which is not collected in the what? Nitrometer. It is calculated and what? Measured. So the other method is what? The Jeddas method. Is it? Okay, Jeddas method. In this Jeddas method, this is how it is. The sample, a given sample is boiled. A given sample is what? Boiled with a concentrated tetraoxophosic acid and anhydrous potassium sulfate. A given sample is boiled with H2SO4 and anhydrous potassium sulfate. That is potassium sulfate. Now, please, the function of this anhydrous potassium sulfate is to raise the boiling point of the acid. You can see that now. The function of this anhydrous potassium sulfate is to raise the boiling point of what? H2SO4. Please, this question is going to come out. Which of these is a function of anhydrous potassium sulfate during the Jada's method of nitrogen demonstration? Please, it is to raise the boiling point of what? The acid. Now, what will now happen? Now, since we've arrived here, now catalysts containing maybe mercury, a catalyst containing mercury and is it selenium now? Okay, is it tritanium? Is it tritanium? Okay, good. Any catalyst containing mercury and what? And tritanium is added. Alright, as soon as it's added, the summation of what? Ammonium sulfate. As soon as these catalysts are added, ammonium sulfate is what? Formed. Now, after the formation of this ammonium sulfate, sodium hydroxide is what? Added. As soon as it is added, ammonia is what? Formed. Let me do it. I have SO4 plus sodium hydroxide. I'm going to be having what? Ammonia. I've taken one H from here. I'm left with what? One H. And we have that one H that is left here, add to this compound, this OH. I will now have what? Water. So I'm left with what? SO4 and Na, and that becomes what? Sodium sulfate. So for me to balance the equation, how many oxygen do I have there? How many oxygen? Okay. So that is it. That is how it is. So please, Dumas method has been explained. Okay, Jada's method has what explained. The first to do is to boil the sample with H2SO4 and what? Potassium, anhydrous potassium what? Sulfate. The function of this idiot is to raise the boiling point of what? The acid. Now, some catalyst is added, having mercury and what? Tritanium what? That is, you cannot say tritanium what? Amalgam. To form what? And that is ammonium what? Sulfate. As soon as ammonium sulfate is formed, sodium hydroxide is added to form what? Ammonia. Look at it here, ammonia. So at this point, we'll call it a day. In my next video, I'm going to be solving questions on what? Molecular, empirical formula and molecular what? Formula. So at this point, we'll call it a day. If you know you have learned something, please endeavor to subscribe, like, share, and comment. Please do not forget what we've done so far, the Prussian blue, the nitroprusside, how, when, and how are they used. Please do have a wonderful day.